Welcome everybody. Welcome to our backend webinar. First of all, I am Michelle and I'm responsible for the marketing within Elements. But luckily I have two amazing colleagues who are going to give this webinar about backend to you. First of all, we have David. He is going to talk to you about monitoring microservices. And after that, we have Mattias, who is going to talk about scaling DevOps. Please try to mute yourself as much as possible to avoid any noise. And if you have any questions, you can just ask them in the chat, and I will try to find the right time to ask my colleagues within their talk. I just wanted to say, I think you got a notification, but we are recording this meeting because maybe we want to share it later, or we want to see like how everything went. And of course, if we are going to share it, we will not have any names or anything in it, so don't worry about it. But I just wanted to tell you that we are recording the meeting. If there are no further questions, then David can start his talk.
Okay. Hello everyone, welcome. I am, as Michelle said, I am going to talk a bit more about monitoring microservices, and in a very specific way, using Kubernetes and Istio service mesh, and not only monitoring but also controlling and handling them. I am very sorry for this because it's going to be a lot of information in a very little time. So let's hope. At least my idea is that you have a feeling of how Istio works and what you can do with it, and not going too deep into how you make it work. So in the next half an hour, I will talk about what Istio is, what are the concepts, the basic concepts that Istio has, and I'm going to hopefully go through a demo and showing you a couple of usage scenarios that are, I think, very common in every application that you deploy. And after that, or in the meantime, you can ask questions and I hopefully will be able to answer. So Istio is a service mesh. I assume everyone at least has a knowledge about Kubernetes, so I will just skip that. Istio is a service mesh that you can put on top of Kubernetes. And a service mesh is just a layer of infrastructure that you can define with manifests, same as basically every Kubernetes application. And a service mesh, usually they give you observability, so you can know how your entire infra is behaving in any point in time. Usually also they allow you to manage how the traffic goes inside and out of your mesh, and deals with security, the communication between the services and communication to outside of your service mesh. But some other meshes have additional functionality, like Istio. Istio can help you doing A/B testing, can help you doing canary releases, rate limiting any of your services or your whole infra, can help with access control, who can access what endpoints in your services, and helps you with end-to-end authentication. That is important, especially when you're dealing with security-related applications. And it gives you a lot more that I just cannot say in this talk, but you can feel free to go to Istio and check it. So Istio, as I said, is traffic management, gives you traffic management possibilities and observability. And I'm going to just briefly discuss 4 of the concepts for traffic management. Those are virtual service, destination rules, gateways, and service entries. And a virtual service is, if you know Kubernetes, is just like a superset of the Kubernetes service itself. But it gives you possibilities to create routing rules. So if you have used a reverse proxy like Nginx, then you know that depending on the request, depending on the domain that the request comes to, you can route to the upstream. So you can do that with a virtual service. You can also do things like timeouts, you can specify if the upstream doesn't reply in 2 seconds, then it's a timeout and you deliver the fault to the user. You can inject faults. That is useful when you are testing the application. You can schedule retries. If one of the services you're trying to route to has a failure, you can tell Istio itself to retry without the client having to do it. And on the other side, you can circuit break. If the service is breaking, is failing too much, you can instruct Istio to don't send any more requests there until a certain rule is met. So you stop hammering the service and give it some time to recover. Apart from that, the broader, I guess, of the virtual service is the destination rule. The destination rule is what happens after the virtual service determines where the request goes. So this applies to the service that you are routing to, and in there you can create load balancers. If again in Kubernetes you have one service, but many pods attending that service. So you can, with Istio, decide to which of those pods the traffic goes to in much more control than what Kubernetes can give you. And you define subsets. And this is especially nice to do it when you are doing A/B testing. You can have multiple versions deployed of the same service. And with the destination rule, what you create is you define the subsets depending on tags of the deployment, so the virtual service can route to it. We are going to see a bit more of this later, so I'm going to just go super fast to have time to show you later. The gateways is to define traffic coming in, but also traffic going out of your mesh. The equivalent in Kubernetes would be an ingress, but there is, I think, not an equivalent for getting out of the mesh. So you can define a service that will deal with every communication going out or part of the communication going out of your cluster. And here as well, you can, for the ingress, you can manage your TLS settings. So which certificates are you going to use? And then the service entries is to define out of mesh services. So if you need to control or have rules like timeouts and retries and everything to a service that you don't control, it's not in your mesh, you can create a service entry, you define that service, and then you can apply the same rules as if it was a service that you control. So one of the nice things and the things I like about having this already is that Istio gives you a lot of out-of-the-box ready tools for you. So one of them, and a very nice one, is Kiali. This gives you an overview of all the traffic that is inside your mesh, and this is completely free. As long as you use Istio, you are going to get this. You don't have to do anything for it. You will have a graph saying all kinds of information about the requests, where they go, how they are routed, who calls who, if it's secure, the communication. All of that is done for you if you use Istio. Another one that you have to work a bit more, but not that much, is Jaeger. And this is part of the observability, right? This Jaeger, you use it for tracing. You want to know what happens when a request comes in. So, well, I can show a bit, but also we're going to see this in action. This is a request that came through the ingress gateway, so came from the internet, and this is the whole trace of everything that that request generated. So one application called another one, then that one called another one, and so on. And you can see here all the information. If it failed, you can add more information here from your applications if you want. This is also kind of free. The only thing you have to do is you have to forward some headers in your application so Istio can keep the trace. And this is, I think, the most known to everyone, but it's Grafana. What Istio gives you is they export, of course, all the metrics using Prometheus. So if you have a Prometheus, you can create a Grafana, and they give you, I think it's 6 or 7 dashboards already built that you can just install, and you have all the information from the cluster, and you can compare. So that's a very quick introduction of the concepts. And now I am going to show you a bit, hopefully with a demo, how you would use Istio to solve some issues and also to visualize your mesh. So this is the application that we have. The application is comprised of a front-end API that is the one facing the internet. And that API contacts 3 services. Some of those services are proxies to another service. So this is kind of what you have in a microservice-oriented architecture. One of those services is version. So I have 2 running versions of that. And also the front-end application connects to the internet to an API that you don't control. So that's how the architecture is. And the current state, so the initial state of the demo is Istio is installed, and it's installed using only the registry. This means the services will only be able to connect. Any of your application, any part of your application will only be able to connect to services that are defined in the mesh. So that is, of course, all the services you have, but also the services that you declare manually with the service entries and stuff. There is MTLS between services, so every service has a key pair that will use to expose the service, and all the communication between all your services is encrypted, and it's encrypted with their users. So with Istio, you can say, hey, the home application can go to proxy 2, but proxy 2 cannot go to home, and that is handled because you have MTLS. Monitoring and tracing are in place. All the services are deployed, but then I have some issues. It's not possible to go from the namespace where the application is deployed to the internet directly. That is based on a Kubernetes rule. There is a network policy that doesn't allow me to go to the internet. This is, I think I'm a bit of a control freak, but I think it's a good practice. Then if for some reason you get a container that is trying to reach something that you're not aware of, it's just not going to work. Also, because of that, I cannot reach hdpbin.org. I cannot reach also one of my services. And when I try to go to my versions service, I randomly land in one of the versions. So I'm going to show you the home page of the service, and also the consoles, so you can take a look. So this is my awesome homepage. So the first one is the one. This block is the block that happens when I go to the internet, where I try to go to the internet to the HTTP service, and I just get a gateway, bad gateway. If I try to go to my internal service, that HTTP, it will work. It will just reply with the headers that I sent. And if I go to the version service, I will land randomly, I hope, yes, version 1 or version 2, depending on, a random rule. I don't know what it is. And I cannot reach my internal service call. So I will show you a bit, Jaeger, how it works, and I will not have time to go every time I fix something and show you, but at the end we will go back to this. So this is what happens. The home app, it's telling me, hey, I'm trying to call HTTP and it's giving me an error, and then here you can see all the data of that request. And the same thing for every connection that initial request generated. And then in the console of Kiali, I can see basically how in the last minute, what has happened inside my mesh and what is the traffic going to, color coded. So I know red is not super good. And I can see where the traffic comes from. So 100% of the traffic comes from the internet. And where does it go to, and in what proportion? And if you see all these logs here, it means that the requests are secure. So I am communicating through TLS between the services. And then I cannot. Yeah, Grafana dashboard. Yeah, I will not show this in detail, sorry, in detail, but here I have, like I said, a couple of dashboards for Istio. This comes out of the box. I don't have to do anything for this. So, okay, the first thing I want to do is I want to, this is just a dashboard show that I put up just in case the demo doesn't work. So we want to make it sing. We want to fix the access to the internal service. We want to fix the access to the external service, and we want to route correctly to the latest version of the code. And we want to eventually this service, when we fix the access, we are going to notice that the service fails also randomly. Sometimes it gives a 500, sometimes it gives a correct response. So we want to retry. We want to, the Istio helps us to give a good answer to the client. So first thing that we want to check is we want to fix the access to the internal service because I know how it's set up. I know what it's missing is the authorization for the home app to reach the failure application. So to do that, you use an Istio YAML, an Istio object that is called an authorization policy. And what you do is you match the application you want to reach. So I allow everyone that comes from the namespace demo, that is the namespace where the application is running. And this is the service account. This is all Kubernetes things, the service accounts where that is running that deployment to reach that application. So after you apply it, I'm going to apply it behind closed doors. So after I apply it, you start getting this. You start getting the internal service that before was failing with a 403. You were not authorized. You get, this is one of the times that it worked, but maybe we can hear, oh, well, I reload it and then now I get a 500. And I keep doing that, but then now I got a good response. But yeah, it fails sometimes. I don't like that. The next thing, this is, I think, the most complex of all in terms of the amount of manifests that we have to apply, is fixing access to the external service. Because I have this crazy rule that it's not allowed to go to the internet in the namespace, I want to route my external request through the egress gateway, through an egress gateway, and then that is allowed to go to the internet. So to do that, this is what we want to achieve. So the home application will go through an egress gateway, and then that will go to the internet. And this one is running in a different namespace. In this case, it's running in the Istio namespace. So to do that, we need to first define a service. I want to define a service so it is in the registry that I mentioned at the beginning. I need to define the http://bin.org service. Then I will declare a gateway, an egress gateway, to say, okay, you can go to that service. And then I will do a destination rule. I want my application to communicate to the http://bin.org in plain text. So I don't want to do HTTPS as the application is concerned. But when I go to the internet, I want to have TLS. So that we can do with a destination rule. And then the virtual service is the one that routes the request. So if the request comes from the inside the mesh, route it through the egress gateway. And if it's in the egress gateway, go to the internet. So we're going to see all of that in a second. So as I said, service entry, we define the service. We say when the host is http://bin.org, I have two ports that I listen to, 80 and 443, and I say this is an external service. It's outside the mesh. And here you could say, yeah, the resolution is not DNS. You can put the IPs directly there, and then inside Istio you will have this as a domain that you can reach, even if it's not in any DNS. The next one is declaring the gateway. And this is a selector for the gateway service. This is when you create an egress gateway, you will have a deployment and you will have a service and with a label. You can have multiple egress gateways, as you can also have multiple ingress gateways. In this case, the egress gateway is labeled Istio egress gateway. And I'm saying my gateway is opened in the port 80, and this is the host. That is it. So I now have the destination rule. What I am doing here is I am creating a subset. So I'm saying when I can go to the egress gateway with this URL, and this is a subset, HTTP in org. And you are going to know what this does when we go to the virtual service. And then I have a destination rule that when I try to go to http.org and the port 443, then use TLS in simple mode, so no client certificate. And these certificates are used, these are the default ones, used to validate that the certificate from the server is valid. So this is the routing part. The virtual service, you define the rules. So there are two gateways that I want to use. One is the HTTP.org gateway that we created in the second step. And the other one is the mesh. When you put mesh, you are saying every service in the mesh. So the virtual service rules are applied in sequence. So the first one, if the first one matches, then that's it. That's the one you're going to use. So if the traffic, I'm matching the traffic, if the traffic comes from the mesh to the port 80, then redirect it to the egress gateway. So if it goes to http.org from any of the applications, it's actually not going to hit this. It's going to hit the egress gateway in this subset. This is the subset that we defined in the destination rule. If not, if the traffic originates in the gateway, in the http.org subset, then the destination is http.org and port 443. So I changed the port from the 80 to 443. And then since I have this, the destination rule that applied before, I am going to land on this destination rule. So the host is this one. The port is the same port as in the virtual service. So Istio will do the SSL negotiation for me. And this is happening on the edge of the mesh. So if you want to snoop on the traffic between HTTP and the application that calls it, you can, because in theory is plain text. So now if I apply all those manifests, then I have the external call working. So that's the how you create an external service. I don't know if there are questions, but I'll just continue, push through. I don't see anything in the chat, so it's fine. I just realized that the image is not okay, but now we want to fix the routing of the version service. So it's this flow. What I want to do is I want to achieve that, let me go back to the drawing, that all the traffic goes to version 2. That's what I want to do. And then put an extra rule. If I want to go to version 1, I can, depending on a rule. That is easier, let's say. So I just define a destination rule to split my two versions. I have a deployment with this label, version v1, and I have another deployment with version v2. So I define two subsets, one called v1 and one called v2. And that's it. That's what the destination rule does. And then I create a routing rule that says if the request comes with a header xdemo version old, then route it to the v1. But if the request goes to version 2, if by default, send it to version 2. That's what those two manifests do. And if you remember, if I reload here, this is what you should be checking. The version eventually hopefully, yeah, version 1, and sometimes goes to version 2. It's random. So I'm just going to apply the fix, and the fix is just a manifest. So I just mentioned, and it sometimes it takes a bit of time, but I think for now you will never see version 2 again, except if we send the header, right? If we send the header, if the request has a header that says X version old is true, sorry, it's old, then route it to version 1. And then if you see here, remember that this service just replies the headers that I'm sending. So I am sending that request now, and every time I will get version 1. So I'm routing depending on the request, and this is what you would do if you're doing a canary release, or this is what you would use if you're doing A/B testing, of course with different ruling, but this is the mechanism you use. So that's now solved. The only thing I have is I still have a service that is failing sometimes, and the thing you should do here is go to the service and fix it, but we don't have time for that. We just want the client to not repeat the failure. So let's do it. The only thing we need to create this destination rule I created, but it's the same as the previous times. I just define a subset, and I just say here, if the host is failure, try 5 times if you get one of these errors, and this one is not default. The 500s are not default, so you need to specify to Istio, if the service is replying with a 500, then also retry. So after applying this, you should at least get a lot less failures. I have seen the service failing 6 times in a row because it's just a random number, but we can try. So this one will never say again, or hopefully a lot less 500. It will always listen to me. And then you could come. That's it. That's all the fixes that we needed to apply. But then you can start looking at Kiali, and then you see all the fixes happening. And I reloaded, sorry. And you can see that the amount of requests going to V2 in the last minute is already a lot going to this. But of course, I still have some requests that I did manually into here. I have a for loop doing requests. So here you can still see everything is kind of green, and this one is green now. Before it was, I think, red, but this one is still failing. And of course, the client is not seeing it, but you can see it in your monitoring. And also we can see how it looks if we go to the traces. For instance, this one is a full trace, and you see all the retries that Istio is doing for you until, and this one failed 5 times, and then the 6th one worked. So that's easy. The common things you can do with Istio. Additional things that you can do, but of course I already am out of time. You can restrict or allow access to specific endpoints based on request data, and also not only based on request data, but based on the user. So Istio has authentication plugins, so it can know what the user is, and then depending on that, routing or allowing access. There is a whole plugin architecture in Envoy. You can apply plugins. One easy example is we are building an application that has audit logs, and we need to audit some request responses that we're doing to the external to the internet. And then by just doing plain text HTTP and having a plugin in Envoy that just logs all to standard output, it's super easy to do. And all of that is without doing any changes to the application. You can use Istio to join together different clusters into the same mesh. You can manage clusters, out of cluster services with Istio. So if you have Usually this is done when you're migrating from a VM-oriented architecture that everything runs in a VM to Kubernetes. You can start with installing Istio and then doing all the mesh, and then you gradually migrate to Kubernetes, and it will be transparent. And you can do mirroring. When you're trying to a new version of something, you can tell Istio to every request that comes to this service, or a percentage of those requests, send it also as an exact replica to this other service, but just ignore the response, right? It just so you can see how the service works with the same load as in production. So that's something else you can do, and there are infinite things you can do, and there's just not time to do that. So I am a bit tired, so you can ask if you have questions, or I am sorry of all the information, but I think it's an awesome tool. So ask away.
Thank you so much, David, for your talk. I don't know if there are any questions. People can unmute themselves, or we have actually one question in the chat. What is the state of Istio in terms of development? Is the API stable? It's
not. It's all alpha, but it's used in production already. But it's like Kubernetes. It goes so fast that it cannot be stable. But the changes, I mean, the structure and the concept are very clear, and I don't think they will change a lot, but they can change, like your manifest might change to apply new formats, but it's stable enough. You can use it in production.
Thank you. If there are no any more questions, then Mattias can share his presentation.
Yes. Here we go. Can everybody can see my screen, right? Yes?
Yeah,
good.
We can see your screen.
Perfect. Welcome, everybody. Thanks, David, for your presentation. That was very enlightening. A lot of things to learn, and also a lot of things to play with, I think, for a lot of people. Very interesting. I'm gonna shift gears a little bit and take it a little slower, a little less techy, so we can all go towards the end of our day in a little bit slower pace, and you can catch your breath a little. I'm going to talk about paved roads, scaling DevOps for the enterprise. And my name is Mattias. I've been a software engineer at Elements since 2012. And I'm currently a developer productivity engineer at Denito, which is at a client. And I want to show you today how we as a team are enabling teams within a large enterprise to work with DevOps and work in the DevOps way of working, and help them grow and become more mature in that area, and enable them as a development team. So you might wonder, what does that mean, developer productivity engineer? In short, it's developers enabling developers. And we are an engineering team that consists of only 5 software engineers. We're all software engineers, and we provide solutions and support to other development teams within the organization. And all our solutions are focused specifically to the development lifecycle. That means that from the moment the developer picks up a user story until that feature is released to production. So it does not mean that we offer help in developing the application. We do not code other people's application or support their application when they're running. We are purely focused on the development lifecycle itself, and to help the developers to make that part more productive. And instead, teams are autonomous themselves. They are responsible for the entire lifecycle of their application. So they have to build it, ship it, and run it, and make sure that it keeps running. And also they have to do their out-of-office support, etc. themselves. We don't do any of that. Instead, what we do is we offer teams something that we like to call a paved road, which is all about a proven and battle-tested set of solutions that makes it easier for teams to build and deliver application. It's like you just get in your car, you do your own development, and you don't have to worry too much about everything you need on the way. The road is smooth. Everything that you need is already available to you. And it consists of a set of tools like a Git server, build runners, security quality testing, release management, all those things that you need in the development lifecycle. And the foundation of this is found in best practices that you can find all over the world, from software development communities and different authorities like the Cloud Native Computer Foundation, the Continuous Delivery Foundation, but also, for instance, Google's DORA project, which is basically based on extensive scientific research into DevOps and software delivery and operational performance. So they've really done research in what makes DevOps work, what are practices you need to know. And with that input and combined with the requirements and limitations and the possibilities that we have inside the organization, inside a large enterprise, it leads to a recommended way of working. And in a large organization, you often have a lot of strict regulations and limitations due to, for instance, stock market or financial regulations or government. So it's always a mix, and you can't always use everything that's out there. So what we do is we figure that out for the teams so that they don't have to figure it out themselves. So teams don't no longer have to reinvent or invent the wheel when it comes to setting up their CI/CD project, where to put their repositories, and what tools they need to deliver their application to a production environment. Instead, we maintain that, we make sure that it's upgraded, updated, and ready to use. And that might seem a bit overkill depending on in what kind of organization you're working with, but let me show you a little bit of how we fit into this enterprise organization, and hopefully you will understand why this paved road concept is actually quite important. So here we are. We're the little D in the left bottom corner, and we're part of a larger infrastructure department that does stuff with public cloud and different services that they provide on top of that cloud, like Kubernetes and other things like that. And of course, our department is part of a larger department, which consists of many development teams, about 100 to be more specific. But that department is again part of a larger department, which holds a lot of other departments, which hold a lot of other development teams. So we are talking about several hundreds of development teams that all build their own application, some of which are more than 50 years old already, while others are just getting started and they can work with the latest and greatest technologies that are available. And this gives us a very wide range of different technology stacks, infrastructure. And while some of these teams will remain on their legacy infrastructure for a long time, other teams might start using newer tools and abilities that are become available, like Kubernetes or even serverless and other public cloud offerings. And you can imagine that it's very expensive if all these teams all figure out themselves how their development lifecycle has to be adjusted if they, for instance, start using serverless. And you might end up with 50 different ways of how the teams all achieve the same, all with their pros, all with their cons. And so instead, it's better that we work together with the teams and create a standardized way of working, or at least a base of how things should work, so that the teams can spend way more time on their specifics, the specific details of their application, things that are specific to their technology or their domain. And of course, within a large enterprise, it's not just that, you have a lot of other challenges that exist. For instance, there's very strict security compliancy protocols. There's auditing that is in place that requires a heavyweight chain process, which means that all changes that go to production need to be registered, need to be provided with sufficient documentation. etc. On top of that, you of course have a large organization, and communication is difficult. Communication, especially across departments, is complicated because they don't interact very often. And we see often that a lot of these teams communicate sort of through us only, because we sort of created a developer community where people find each other. But beyond that, they don't talk with each other, maybe once a year or something like that. And all these teams are also considered autonomous, so they can make their own decisions, they can choose their own technologies, they can sort of, within some boundaries, do whatever they want and choose to, which creates this very diverse landscape of all these technologies that are there. And for us, it also means that everything that we do is at scale. When we come up with a solution, it should not just fit for 10 people or 10 teams, but instead it should be working for 100 teams, perhaps. And we should always, everything that we do, we have to consider that. Also, when it comes, for instance, to operational work or support work that we do, if it's very complicated or if there's a lot of manual processes in helping teams on a certain tool or a certain way of working, that's not very efficient for us, since we're only 5 engineers. We cannot be talking with all these teams every day, all the time. So for everything we do, we have to think about the scale that we're working on. It's very important, before we continue, that we consider a team as a unit, and every team, everything we do is aimed at a team. We consider all the team members inside the team equal, so we don't distinguish per se lead engineers or mediors or juniors. We consider them all equal in the team. And when we provide access or share knowledge, we do this always for a team. So teams are also when you look at authentication, they're all represented in an Active Directory, an LDAP, and every team has their own group, and all the members are in that group, and this group can be managed by a product owner or a scrum master. So whenever there is changes in the team, the team can themselves make sure that everybody becomes part of that team, part of that group, and automatically inherit all the permissions related to that. And it's also very important for us to consider the team as a unit whenever we do knowledge sharing, because otherwise we're going to communicate to one person, which is fine if there's an operational question. But if we do some really knowledge sharing, like a presentation or a workshop, it's very important to take the entire team along, so that it's not just on one person to relay that information to the rest of the team, but the whole team is up to speed and nothing gets lost in translation. And of course, teams are autonomous. So while we provide teams with permissions based on a group level, once the team has those permissions, they can also choose to adjust those permissions to fit the specific team's need. If we look at practices and the way of working, like I said, we combine best practices and standards from international authorities and from the community, combined with our organizational specifics and tools. So some very common standards that are out there, of course, are like semantic versioning, or the 12-factor app, which defines 12 guidelines or practices on how to build a web application and how to run it. So we take those as well as a Git way of working. And maybe you don't know, but your Git strategy can have a huge impact on both your speed of delivery and the reliability of your code. And if you're using perhaps Git flow, you might reconsider that strategy and look at some alternative ways of how your code goes from development, from your developer all the way to the production environment. Because if you optimize that, you can reduce in moments of integration, moments of communication, moments of when builds are being done, etc. And we have commit guidelines that are very specific, that allow teams to classify their commits, so that the tools that are there in the process can make decisions based on how you have classified your commits. So while these are not mandatory, they can really help with the integration of the tools and the way of working within the team. Obviously, a very important part is the tooling. There's a lot of tooling out there. There's lots of possibilities and changes and new technologies that show up all the time. And one of the most important things we consider is having a single login, right? You should have only one username and password that you use for all of these services. Otherwise, it will go crazy. And it might work with a password manager, but it can be very frustrating if you forget what is my username for this or my password for this environment. Like I said, we apply group-based permissions for a specific team, and we provide tooling as much as a service as possible. And what I mean with as a service is that the team actually gets a whole tool dedicated to the team itself, which enables us to provide as much permissions as possible. We like to make people on teams administrator of their tools so that they can install what they need, make the changes that they need, and they're not bound by or dependent on us as 5 developers to provide them and change settings for them, etc. Right? It really maximizes the team's autonomy in that sense, and also helps with the scalability because we don't have to make every single change or adjustment. But at the same time, we take care that everything is secure, everything is compliant, everything is tested as much as possible. We keep everything up to date, etc. Now, that's all great, but in order to serve all those teams, we cannot just handle requests on demand. So we started to do self-service to make ourselves more scalable and make teams less dependent on us. So first of all, there's a self-service portal where teams can onboard themselves, where they can put in requests, where they can deploy new tools if they want to request services. But also, for instance, when we migrate tools, we can't always do that without downtime or without impact. And so we offer a way for the teams to migrate on their own terms, on their own time, whenever they want to, basically providing them a click of the button, and we give them a timeline like, hey, in the next month or so, you need to migrate from one environment to the other. You can go into the self-service portal and click that button, and it takes about an hour, and then you're good to go again. You know, it really gives the team the control themselves to manage this and do it at a time that suits them best. And we keep innovating on this and making more and more possible through the self-service portal as we go, which also reduces the amount of time that we have to spend on doing manual processes that could easily be automated. To do this also, we leverage Kubernetes public cloud using templates and APIs to enable all this automation, to deploy these tools and services into the cloud whenever it's requested. And it also gives some kind of a unlimited resources in that sense. If a team wants to have one Jenkins, or if they want to have 2 Jenkins or 3 Jenkins, they can deploy basically as much as they want. Of course, if they deploy 10, we're going to ask the question like, hey, we see that you deployed 10. What's your use case? Because do you really need this, or is there some other way we can do this? Because of course, resources cost money. And also, we recently started to introduce chat ops, where we have a chat bot that can help us to automate some things and ask for more feedback when a user asks questions, or give automatic replies to common requests. And to get a little bit more technical for you, because this is a tech talk, we have our user portal, which talks to a backend. It has an authentication provider, which talks OpenID Connect, which then talks to an LDAP service. So it ensures the authentication, and we get to know who are which are the groups that you're a member of, which are the teams you're a member of. The backend then can do things through Jenkins or Kubernetes or different cloud providers to provision whatever the team requests, as well as talk back to the LDAP to create groups, for instance, or make people member of groups on requests, and automate that process, as well as it talks to several other applications to automate processes around permissions and things like that, like creating projects inside our Git server or permissions for artifact storage. This is all fun, but it all stands or falls with whether or not people start actually to use this, right? And like I said before, we don't force a way of working on the teams. We offer something, we offer a solution. And the only way people are going to use it if it's the best thing available. And it might not be the best thing out there in the world, but at least the best thing within the organization, right? And so we should be really well available also for support for the teams whenever they have questions, to respond quickly, respond with the right knowledge, and help the teams out whenever they have questions. And we can reduce that a little bit by making sure that we have good documentation, good examples that people can use, that people can see. And by creating examples and by creating and using our own tools for our own self-service portal, for instance, we make sure that we eat our own dog food, so to say, which is really important, because often what you see is teams offering services but not using them themselves, and then the users get really frustrated because it's not working the way it's expected, or working for their specific situation, which can be really frustrating. And by using our own tools ourselves, we can continuously figure out what is frustrating to the user, what could be optimized even further, etc. And the last, but definitely not least, is things about awareness. We need to make sure that we create awareness, that people know about our stuff. So we're part of onboarding. We take people on a treasure hunt where they discover our tools. We have big tech events that are much broader than our tools, where we invite guest speakers from over the world, etc., to talk about DevOps and inspire people. But of course, it doesn't always fit. There's a lot of different technologies, and especially when it comes, for instance, to SaaS, it becomes a little bit more complicated. So there's something that we call off-road, where people take their own stuff, they try it out. It can be a lot of fun. You can discover things, but it's also bumpy, dirty, and it requires a lot more subject knowledge and knowledge about and taking care of things like infrastructure and licenses and security. And your custom solution might really work for you. It might work not for others. And we try to be involved in the process, or at least talk about that process, to see why you need to go off-road, help you with the choices you make, see if we can actually make it on-road. But especially when it comes to SaaS, we often see that teams really need to have a specific solution that are very specific to that vendor, or that specifically are created by third parties that really are dedicated to those solutions, to those services. They're never going to be a generic thing for all the other teams, but they're needed for them, because although the principles that we share with the team still apply when it comes to CI/CD and your way of working, you just simply need different tools to make it work for your specific environment. And so that's where we allow teams to go off-road, and we're there to still support them a bit, but we can't support them fully, and we're not going to run those services for the teams. But sometimes there's a new tool that comes out there, or a new way of working that the teams start experimenting with, and we think like, hey, that's great, we can use that. This is something that's useful for other teams. And that is one of the ways new roads are created. New roads are paved, and we work together with teams and figure out like, hey, this works for you. How can we make this scalable? How can we have other teams use this as well? And this can come from teams, it can come from us, it can come from the infrastructure, other infrastructure teams that say like, hey, we have a new technology or new service available. Let's figure out a new paved road for this specific solution. And together with others, we pave new roads, and we discover new ways to do basically the same, but with different technologies. So that's a bit about paved road. So if you are in an organization and you want to do something like this, these are some points of strategy that we apply. So like I said, we consider teams as a unit instead of working for individuals. Something else that I didn't mention yet, but we target about the 90%. There's always a lot of edge cases and things that teams want or need that are very specific to them, or they just want to explicitly work in a certain way, either because that's just how they are used to it or how they like it. We can't make everybody happy with everything that we provide. So we target the 90%, try to work with the exceptions when it comes to requests, try to also allow like a manual or an alternative approach to it. That way teams can still use most of our paved road often. Again, provide most possible access to teams, make sure that they get as much permissions as possible so that they're not dependent on you as a team to achieve certain goals, and support them, right? They might have access but not know how to use it. That's where we support them and tell them like, hey, give them instructions or provide documentation, which is important to have it in a central location, right, together with your self-service, so that the users have one entry point. Whenever they need something, they can go to one place, and from there you might deep link into your wikis or other websites that you have, but go to one place as a starting point. That makes it very easy for the users to find things. Automate the processes that are repetitive, that you do very often, that might be really frustrating to do, but that are very common or easily automated. That way, everything that's automated scales a lot faster if it's just a press of a button, rather than you have to go into different systems and click around and handle emails. It makes things so much easier. And very important is to also get feedback, right? It's great if you provide service, but if your users can't use it or if they run into trouble, we're trying to enable users, we're trying to make them more productive. If we're making them less productive by pushing them in a certain direction, that's not a good thing. So we have to constantly be in touch with the community, with the different development teams, try to connect with them so that they are heard, that we make sure that we enable them, that we innovate based on their needs as well. All right, so those are some key points also if you want to do these things. And well, that concludes my explanation about the paved road and the way that we scale DevOps within enterprise. Thank you for your attention, and it went really fast, but you can ask questions now and provide us feedback and share any ideas or things you want to hear in maybe an upcoming webinar. And I'm going to hand it over to Michelle.
Yes, thank you so much, Mattias, for your talk. We have actually one question in the chat. It says, okay, long question. Sometimes it's difficult to justify the benefits that the paved road can do to your company, and the most resources are allocated to clients' projects with very little time to non-productive tasks. So what would be your elevator speech to try to sell this to a company which doesn't have any specific DevOps teams? Asking for a friend.
Asking for a friend, nice.
Yeah.
Well, I mentioned in the beginning, Dora, which is it's now part of Google, but it's basically DevOps research, and they have a very clear explanation and scientific research that points out like what capabilities and technologies and practices really benefit software development and how they benefit software development. And I think that's a good starting point, because it really shows and it really gives you the foundation and the facts and scientific research to prove to the client that this is really valuable and that this is actually in the midterm or in the long term gonna benefit their process and benefit their application. Because what you see is that if teams that apply these practices, and that's way more than I just talked about, but if teams apply these practices, you see that they become high-performing teams that deliver faster, are much more likely to exceed business requirements and business goals, have much less or many less incidents and issues, and really have a faster time to market, as well as delivering innovation. So I think that's really a good starting point there. I might be able to share a link, but you can search for Dora. It's spelled exactly the name as that character that your kids might be watching on TV. And search it in combination with Google or with DevOps research. And they have a couple of documents called Accelerate State of DevOps Those are reports. They're very interesting to read about the subject, as well as on their website. They elaborate a lot on all these different practices and how they should work in reality.
Yes, thank you so much. I see David shared also a link in the chat about what Mattias was talking about.
Perfect.
If there are no more questions, I would like to thank David and Mattias very much for giving this webinar. And of course, I would like to thank everybody else for joining. If you want to be up to date about our next webinar, you can follow us on Meetup or one of our social media platforms. We'll also announce it over there. Yeah, I would like to thank you again and wish you a very nice evening.